Hello everyone, welcome to the Big Data tutorial series. This session is the second session of this series. In this session, we will be discussing about HDFS and lots of practicals on it. If you have not watched our previous video on Introduction to Hadoop, it is suggested and recommended that you refer to it first before watching this video. Let us start with today's session. And let me introduce myself first of all. My name is Rajan Chhetri, and I'm the Big Data instructor for this program, and I will be sharing my experience and knowledge on big data. So let us understand what we'll be covering in this session. So this session is dedicated for HDFS, which stands for Hadoop Distributed File System. Initially, I'll be explaining what HDFS is and what are the various characteristics of HDFS. We will be getting deep dive into the architecture of HDFS to know more internals and in-depth detail of HDFS. Now, once we are clear with what exactly is HDFS, we will be getting our hands dirty with the HDFS commands. There are lots of hands-on exercises and practicals that we'll be doing in today's session. So let us start with first of all, what is Hadoop Distributed File System? In the previous video, I explained about the Hadoop and its architecture, in which we had a basic understanding of what HDFS is. I'll give you a quick review of what exactly is HDFS by drawing a visual here. So as we know that Hadoop is basically a framework which is for distributed storage and parallel processing. It works on a master-slave architecture. Generally, we call it Namenode. We refer to the master, and the data nodes, we refer it to the slaves. So, what is the purpose of these data nodes basically? These data nodes are meant for two things. One is for storage. Second is processing happens here in the data node. Now, HDFS doesn't deal with processing or computation of data. HDFS mainly deals with the storage. So what exactly is HDFS basically? HDFS refers to the storage in the data nodes. So here, basically we're talking about the hard disk. In terms of hardware, it is hard disk. And so this hard disk or the storage of all the data nodes is managed by a software program called HDFS. So HDFS is basically a distributed file system. So what exactly is distributed file system? So because it is a multi-node architecture, you can see here when the data is stored in this cluster, the data is basically splitted across various data nodes. So HDFS is basically the file system which takes care of storage of the data across multiple systems, and HDFS is basically an application or the software which will help us in retrieving the same data as well. So here, as a summary, if I want to create a visual of what exactly is the HDFS, HDFS refers to the storage of the data nodes, and it deals with the file operations in terms of storing the file across multiple data nodes, retrieving the data from multiple data nodes, and listing the data, removing or creating some directory or the data. Now, HDFS is basically inspired from Google's GFS, which stands for Google File System. Now, HDFS provides us the replicated storage for data using cheap commodity hardware. It basically means that for running HDFS or for using HDFS file system, we do not require any expensive or special kind of hardware. We can use this file system across any in general hardware which is commonly available to all of us. Now, HDFS provides us replicated storage. It basically means that for every data, we have a replica of it available in the same file system. It means the duplicate copy. Now, the duplicate copy of the data is created just to prevent the loss of data in case of a node failure. HDFS is not designed for small files or huge number of files of smaller sizes. HDFS works well when when we have small files which are huge in size. In case if we have small files of lower sizes, smaller sizes, then we're going to see a performance degradation. HDFS is basically taken care by name node and data node process. Now, what does it mean basically? There are some softwares which are running in the masters and the data node. So, the process which is running inside the master is called name node, and the process which is running inside the worker node is called the data node process. So, name node and data node, basically, do not confuse it with the vocabulary of master and slave. They are also the running processes. Now, HDFS is only available or it is only accessible only if the name node is running. That's right. So, we cannot access the storage of the data nodes without the availability of the name node. Now, why is it so? In order to understand why the HDFS is not available without name node, let us look at a picture here. If you look at this picture, it will be very easy for us to understand why the HDFS is not available without name node. So first of all, at the bottom that you can see here are basically the data nodes. The green blocks that you can see here are the data. Now here, if we have any file, let's say if we have a file of size, let's say some 1 GB, this file will be splitted into blocks. Now this happens when we try to push any data into the cluster or into the data nodes. Whenever we try to insert any file or push any file into the cluster, the file is first of all split into blocks, and each block will be of 128 MB each. So here 1, 2, 3, 4 and 5 are basically the blocks. So there will be more blocks here because it is of size, let's say 1 GB. So here the green blocks must be easy to understand now that these are basically the splitted chunks of the whole file. One thing that you can notice here or you can observe here that we have duplicate blocks here. You can see here. And similarly, we have the duplicate blocks for other blocks as well. So this is basically called replication. Replication is beneficial in case of if there is any fault. Let's say if this data node or this machine is not available, and if this machine goes down, we can still retrieve the block 4 from a different server machine or from a different data node. This is called fault tolerance. Now previously there was a question that if the name node is not available, the HDFS won't be available or the HDFS will not be accessible. Why is it so? So first of all, let us understand what does HDFS not available means. When somebody says HDFS not available, that basically means that we won't be able to retrieve or store the data into the cluster. Yes, we won't be able to retrieve or store the data into the cluster. That basically means HDFS is not available. Now this information that you are seeing here is called metadata. What exactly is metadata? This first of all, this metadata is contained within name node, or this is maintained by name node. What exactly is metadata? Metadata is basically the information about the addresses of the blocks. So metadata contains which file is stored in the cluster, it also consists of the information what is the replication factor. It means how many duplicate blocks are there for each block and in which data nodes they are. So, in simple words, as a summary, I would say metadata is like an address book. And this address book consists of address of the blocks. If the name node goes down, which is where this metadata is kept or maintained, then we won't be having the information about the blocks. So this is the reason why it is said that if the name node is not available, HDFS will not be accessible. I hope that is understood. So I'm sure you have understood the replication as well as HDFS. So let us give it a quick summary here exactly. So HDFS, as far as what we have covered, is basically a distributed file system. It is designed to run on a commodity hardware. It has many similarities with existing distributed file systems. However, the difference from the other distributed file systems are significant. And what that is basically, HDFS is highly fault tolerant and is designed to be deployed on a low cost hardware. HDFS provides you high throughput access to application data and is suitable for applications that have large data sets. Now, let us understand what are the various features of HDFS which makes it more powerful. So, the goals which were kept in mind while designing HDFS to be used in the production areas are basically listed here. Let us discuss these goals one by one. The very first goal which was kept in mind while designing the HDFS is hardware failure. Now, hardware failure is the norm rather than the exception. An HDFS instance may consist of hundreds or thousands of server machines, each storing part of the file system's data. The fact that there are huge number of components and that each component has a non-trivial probability of failure means that some component of HDFS is always non-functional by nature. Therefore, detection of faults and quick automatic recovery from them is a core architectural goal of HDFS. HDFS is new, like while designing HDFS, it was already known that because it is a multi node cluster, there is a high probability that any of the server machine or any of the data node can go down or can be out of order. So it has built-in recovery system which can prevent the loss of data or any computation which is running currently. The second goal which was kept in mind and it is a feature which is there in HDFS is streaming data access. Now the applications that run on HDFS needs streaming access to their data sets. Now, in order to support streaming, basically the underlying file system, which is POSIX, is customized, or you can say it is molded in such a way that there is high throughput, which is available in HDFS, which is very much needed for the streaming data access. Now, the third goal, which is there and is available in HDFS, is the capability is the capability to handle the large data sets. Applications that run on HDFS have large datasets. A typical file in HDFS is gigabytes to terabytes in size. Thus, HDFS is tuned to support large files. So, HDFS is designed and is capable of handling files which are from from size of gigabytes to the size of millions of to the size of terabytes and from the quantity of let's say some few hundred files to millions of files in a single instance or in a single cluster. Now the next feature which basically makes the HDFS more capable is moving computation is cheaper than moving data. It basically means that HDFS is designed to execute the computations on the most nearest data which is available in the cluster. Now, HDFS works on the principle of data locality. That basically means that it is going to process the data which is locally available with the data nodes. It is not going to move the data in order to process that data from one machine to another machine, which makes your HDFS computations faster. Now, the next feature which makes HDFS more capable and versatile is portability across heterogeneous hardware and software platform. HDFS has been designed to be easily portable from one platform to another. Now, this facilitates widespread adoption of HDFS as a platform of choice for a large set of applications. So, these were some of the points which basically makes HDFS more powerful and versatile behind its global adoption. All right. So now let us try to understand the HDFS architecture. HDFS has a master slave architecture. So in HDFS cluster, it consists of basically the name node that serve as a master and the data nodes which serve as a client. Now name node is basically can be visualized in this way and the data nodes can be visualized this way. So these are the data nodes. Now, what is the purpose of name node basically? The name node basically manages the whole cluster and it basically manages the metadata most importantly. So, as I explained earlier, metadata is basically the information of your blocks which is kept in the data node. Now, name node also takes care of the data nodes and their availability and it basically keeps a track of which data nodes are functional. Every data node in a cluster basically sends a signal to the name node which is called heartbeat. A heartbeat is basically a signal which signifies that that particular data node is available. Now here, clients are basically used for, uh, you know, clients will be using the cluster for reading or writing purpose. So here you can see that the client can access the data for the reading purpose from the data nodes. Now the data nodes will have the blocks in it. Now clients can also write the data into the cluster. These data nodes are further organized into racks. Now racks is basically a data node organization mechanism in which we organize the multiple data nodes. So here to organize hundreds of data nodes into a group, we have something called racks. There is one more concept in HDFS which is called rack awareness. In rack awareness, while reading or writing the data, the name node chooses the, the data nodes which are in the same rack for the faster access. Now, let us explore this architecture more in detail here. So, there are a number of data nodes, usually one per node in the cluster, which manages storage attached to the nodes that they run on. HDFS exposes a file system namespace that allows user to be stored in the files. Internally, a file is split into one or more blocks, and these blocks are stored in a set of data nodes, as I mentioned earlier. Now, the name node executes the file system operations like opening, closing, and renaming the files or directories. The name node also determines the mapping of the blocks to the data node using the metadata. The data nodes are responsible for serving read and write requests from the file system's client. The data node are also responsible for block creation, deletion, or replication upon the instruction from the name node. So most of the operations are performed by the data nodes when it is instructed from the name node, and name node will provide the instructions only if requested from the client. I hope the picture of the HDFS architecture is clear among all of us. I am very much sure that we all have understood what HDFS is and what are the various features that makes HDFS so powerful. We also know the internals of HDFS using the HDFS architecture. Now is the time to explore more in HDFS by doing some practicals on HDFS using HDFS commands. So in the following demonstrations, we'll be doing a lab, and in this lab, we'll be exploring how to interact with the HDFS using something called HDFS FS shell. So in order to implement HDFS commands, I'll be using an application which is freely available to us, and that is called Cloudera Distribution. This is Cloudera virtual machine. Now, this virtual machine is freely available and downloadable from cloudera.com. As this is a virtual machine, so here I'm using the VMware workstation, which is easily available from VMware website. So assuming that you will be able to download the VM and you'll be able to install the VMware workstation, let us start with the practical here. In order to get started with the HDFS, first of all, let us turn on the virtual machine here. Now you can see here the virtual machine is ready to be used. So first of all, let us learn how to get started with this virtual machine. So first of all, let us close this browser and we will open the terminal by clicking on this icon. Now this terminal will be used to interact with the underlying HDFS file system. First of all, let us check the Hadoop version. For checking the Hadoop version, I'm using a command here called Hadoop space version. So here you can see the Hadoop version, which is 2.6.0, and the Cloudera Hadoop version is 5.13. So here doing the practicals, I'll be using the Linux commands, and in case if you're not familiar with the Linux commands, it is suggested to refer to the Linux commands first of all. I'll try my best to keep the explanation as easy as possible, so let us start with some of the basic commands here. ls. ls is for listing the files of the current directory. So you can see here, I've got some files and folders in my current directory. Now what my current directory is can be checked from the pwd command, which is present working directory. So here I will be following a set of sequence commands to get my task done. The objective is to play around with the HDFS file system. Right now, am I playing with HDFS? No, I'm not playing with HDFS. This is basically the local file system. We need to understand or differentiate between what is the local file system and what is the HDFS file system. So let me show you the files and folders of HDFS. So for viewing the files and folders of HDFS, we'll use a command called HDFS dfs-ls and / which is root. You can see something common here, which is ls. So let us hit enter. Now, if you look at the output here, you can see that the output is different in both the listings. So when I say listings, it is basically the ls command. Now, why is it so? The difference is because here we are viewing or seeing the local file system or the files and folders of the local system. Whereas here we are not seeing the files and folders of a local system or a local file system. It is basically the files and folders of a cluster. To give a better understanding of all these explanations, let us create a visual here. So this is how a cluster is supposed to look like. We have name node, we have data nodes. Now HDFS represents the storage or the file system of your data nodes. So this storage of your data node is represented by HDFS. Now when you execute the ls command, you are viewing the files and folders of your local system. So for example, let's say if there is a client and he is issuing commands such as ls. So basically this means that the files and folders that are going to be listed will be retrieved from the client's file system or from the client's hard disk. So here, by writing ls, the client is viewing his own files and folders or the files and folders which are residing in his own system. But when you execute HDFS DFS -ls slash, it basically means that you will get the listing of all your data nodes. You will get the files and folders of all your data nodes in a single view like this. So here, when you're getting the information about the directories, it is not specifying that this directory is from data node 1 or this directory is from data node 2. Instead, you are getting a collective view of all your files and folders which are residing in all of your data nodes. So I hope you have understood what is the difference in ls and HDFS DFS-ls. Now generally you will see that all the Linux commands that will be using on HDFS will be prefixed using HDFS space DFS -ls. I'm sorry, only HDFS space DFS. Let us check the summary of our cluster. HDFS DFS admin -report. Now this is the command that we use for checking the summary of our cluster. You can call it as a reporting tool as well. So let us hit enter. So here you can see that I've got some information here. So here, this is the total capacity of my cluster. The total cluster can store 54.51 GB of data. Currently or presently, 43.57 GB is usable, and out of which this can be used. Now this is currently used DFS, means I have already consumed 832 MB of data, which is 1.86% of the total space which is available. Similarly, we can see the data nodes information here as well. So right now you can see that I have only one data node which is available. The IP of that node is this, and this is the file system information of that particular data node. So I hope This command will be quite useful for you to understand the summary of your cluster, or you can say the report of your cluster. Now, there is something called safe mode, which is very important for all of us to understand. Now, safe mode is one of the mode of your cluster. Safe mode is generally used for maintenance purpose. There are a few commands that are used to check if the cluster is in safe mode or not. So you can use HDFS DFS-safe mode get. Just give me a moment here. So you can see here, currently the safe mode is off. I can enter into the safe mode by typing HDFS DFS admin-safe mode enter. Oops, it is DSF here, DFS. You can see here, right now the safe mode is on. Similarly, I can write HDFS DFS admin-safe mode leave. So you can see here, right now the safe mode is off. I hope that will be useful for you to work with the cluster. Let us explore some more commands on HDFS. But before that, we have to do some basic operations on the local file system. So first of all, let us check the current directory here. It is /home/cloudera. In the current directory, what are the files and folders? You can see here, there are some files and folders. Now here you can see desktop, which is representing the desktop here. Let us enter into the desktop. So for entering inside a desktop, we will use cd desktop. So you can see here, right now, my current location and desktop both are same. So let us do pwd here once again. Now here, in this desktop, we will be doing the various set of operations on local system as well as file system of the HDFS. So we will be seeing a sequence of commands that I'm executing. First of all, let us create a directory in a local file system on desktop. For that, I'll be using mkdir command. Mkdir is for creating a directory. So let us create a directory called HDFS lab. You can see here the directory is created. Let us enter inside this directory. So for that, we will write cd HDFS lab. So right now, my terminal is inside the HDFS lab directory. Let us check the current location here. You can see here, I have got this path, which is my current location. Here, we will create a blank file. Now, this blank file will represent a data set. So, for creating a blank file, I am going to use a command called touch. So, the name of this file is dbinfo. Now, this file is a blank, empty file and is representing some data, some data set. Let us edit this file and let us write some data inside it. For editing this data, I'm using the vi terminal or the vi command. There are various ways of editing the data, so I'm using vi here, vi dbinfo. Now this is basically a code editor which is generally available across all the Unix-based systems. To enter anything, to edit this file, we'll press I, which is basically the insert mode. Now we can type some information here. So this is a fake data. Once we have prepared the data, let us press the escape key and :WQ for saving the file and hit the enter. So here you can see that there is some data inside this file. Let us print the data. For printing the data, I'll be using a command called cat. Cat is for printing the contents of the given file. You can see here we are able to print the content of the file. Right now, we have not worked on HDFS. This is basically the local file system. What we have done is basically we have prepared a data on the local file system. The objective of preparing this data on the local file system is to make the learners understand how you can push the data from local file system to the or into the cluster. So first of all, let us list the files and folders of the cluster. For printing the files and folders of a cluster, we will use HDFS dfs-ls and root, which is slash, as the command. So here we are printing the content of the root directory inside the cluster. So you can see here we have got lots and lots of directories here. There is one directory called /user. Let us try to print the content of the /user directory. HDFS dfs-ls/user. Now this will provide us with the content of the user directory. So you can see here I've got the contents of the user directory. Let us try one more time. Let us try to print the contents inside /user/hive directory. So we will write HDFS dfs-ls/user/hive. So here you can see that it is printing the warehouse. So I hope you have learned how to list the contents of a given path or a given location in the cluster using the HDFS commands. Now let us try to create our own directory inside a cluster. So I will be creating a new directory inside the user, and that directory will be called upGrad lab. For creating a directory inside the user directory, we will use mkdir command. So HDFS dfs-mkdir/user/upgrad lab. Now please observe the command that I'm using for creating a directory here. The command is hdfs space dfs space -mkdir space the location. Let us hit enter and let's wait for some time. Alright, so there are no errors. Let us verify whether this directory is there or not. To verify the existence of this directory, we will use the ls command, hdfs space dfs -ls, and we will check the content of user directory. So here you can see that I have successfully created a directory in a cluster, and the name of the directory is upgrad lab. Now let us try to remove the directory. In order to remove the directory, we will use a command called rmdir. Let's try it. HDFS DFS -rm dir /user /upgrad lab. Now in Linux, the paths are case sensitive. Make sure the spelling and the case matches. So the command that I'm using here is -rm dir. So let us execute this command and let's verify whether the directory is removed or not. So we will list the contents of user directory once again. So we can see here upgrad lab directory has been removed. Now we will learn how to push the file from local system into the cluster. And for that, first of all, we'll be repeating the steps of creating the directory. So HDFS DFS -mkdir /user /upgrad lab. So here I'm creating a directory called upgrad lab once again. Now I'll not be verifying it because it is already there. If you want, you can pause the video and you can verify it. Now we wish to push this file which is there in the local system into the cluster within this location. And for doing that, we'll be using a command called put. So let us explore how to push a file from local file system into the HDFS cluster. HDFS DFS -put, which is used for inserting the file. The name of the file is dbinfo. Please observe that I'm not using a full path here. The reason because the file is in the same location. If the file is at a different location, you will be specifying the full path here, this way. So here, because the file and the current location are the file and location and the current location both are same, so I'll just use the name of the file, which is dbinfo space, and the next is the name of the location in the cluster. So here, provide the path in the cluster. So in the cluster, the path is /user /upgrad lab. Now let us hit enter. The file has been pushed into the cluster at the given location. Let us verify by listing the contents of the upgrad lab directory. How we'll do that? HDFS DFS -ls /user /upgrad lab. So here you can see that dbinfo file is present in the given location. So this confirms us that using the put command, we were able to successfully push the file from local system into the cluster. Let us try to print the contents of the file. For printing the content of the file, the command is cat. So here you can see that the contents of the file remains the same in the cluster. Now let us learn how we can retrieve the file from, from the cluster into the local system. So in the next command, we will see how we can retrieve the file from the cluster into the system, local system. And for that, we'll be using the get command. So HDFS space DFS hyphen get. Now here, first of all, specify the file path in the cluster. So that is slash user slash upgrad lab slash dbinfo. Here, specify the local system path where you want to save the file. So I want to save the file in the current location. For representing the current location, we will use dot and here db backup. Now here you can see that a new file has been created here and this is called db backup. If you open this file, you will see the same content of the db info, but the difference is that this file has been retrieved from the cluster into the local system with the given file name. And for that, we were using the -get command. And finally, we will learn how we can remove the content from the cluster. So if you want to remove the file from a cluster, we will use the rm command. HDFS DFS -rm slash user slash upgrad lab slash dbinfo. So here you can see that I have successfully removed the dbinfo file from the cluster using the -rm command. Let us verify. Slash user slash upgrad lab. So this must be empty. So here you can see, as expected, the output is empty. So in this lab, you must have observed that we have performed the various operations on HDFS as well as on the local system. If I want to give you a summary, then I started with the local file system, created a directory, created a file, created a directory in the cluster, moved the file from local system into the cluster, printed the file of the printed the content of the file, as well as retrieved the file from cluster into the local, as well as removed the file from the cluster. Apart from that, we have the access of HDFS using a web browser as well. So in the next demonstration, I'm going to show you how you can access the HDFS using a web browser. For using a for accessing HDFS using a web browser, we will use the following URL. So here the URL is quickstart.cloudera:50070. So 50070 is basically the port number. And this is a web view of your HDFS and this is the summary page. So this is basically telling us the various information about the cluster. So when it was started, what is the version number, what is the compilation date, what is the cluster ID and block pool ID. You can also see the safe mode here. It is also telling us how many files are there, how many directories are there, how many blocks are there. It is also giving us the same information that we retrieved using the DFS HDFS space DFS admin -report command. This is the name node information and this is the name node storage and various other information that we are getting here about our cluster. Now, if we want to access the HDFS, for that we have to go to the utilities and we have to click on browse the file system. If we click on browse the file system, you can see here the output. Now this output is same as HDFS space DFS slash ls slash. So basically, you are viewing the content of the root directory in the cluster. If you click on user, you will see the directory that we created, and that is upGrad lab. Right now, there is nothing in it because we removed the file. Let us push the file once again, slash user slash upgrad lab. And now let's refresh it. So you can see here the same file dbinfo. The maximum block size which is allowed is 128 MB. Currently the size is 95 MB. We can see the various other details here, such as the permission and the replication. So this is a web browser based view of your HDFS. This web view basically allows you to browse only, but if you want to manipulate the file system, you have to follow the HDFS commands here using the HDFS shell here.